for? Do you have any clue what coterminal means? Okay, well then you're going to learn something. And then how about angular frequency and angular velocity? All that means is, let's say it's, for instance, a saw blade spinning around. It's going around and around and around and around and around and around. Could you talk about how fast that's going in terms of miles per hour? You could. It's kind of weird though, because it's going around in a circle. It's not really going anywhere. I mean, it's looping around and around and around and around. But you can definitely figure out miles per hour, and that's what we're going to do today. All right, so first off, let's talk coterminal angles. Let me just go off to the side here. And would you please just draw a circle? And on your circle, draw this line that goes out from the middle. Because to understand coterminal, you got to know where angles always start. It's like it starts from there, and then it rises up, and then it stops, let's say, there. That's where it terminates. Okay, so that's where it stops. So it starts here at 0 degrees, and it stops here at, let's say, pi over 3. And if you're like, what are you talking about? That's radians. And if you're still like, what are you talking about? Quick reminder, whenever you think pi, think 180. Because remember, here's where pi is. This is 1/3 of the way to pi. And pi is where 180 degrees is. So you think pi is like 180. Do you get how you can go 180 divided by 3 and you get 60? So pi over 3 is really like 60. Okay. So that's a 60-degree angle, and it stopped right there. Would there be another way to start here and stop there? Yeah, you could have gone all the way around this way, and you'd still be stopping in the same spot. So those angles are stopping in the same spot, and therefore they are what is called coterminal. And we can't say they're exactly the same because this angle went the other way. So we say that angle is going in the negative direction. Now that angle would be negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. I don't know exactly where to write that. I guess I'll write it here. They share the same spot. So negative 5 pi over 3 and pi over 3 are the same. Sharing this, I don't want to say they're the same because they're obviously not the same. One of them's negative, one's positive, but they share the same spot and they get you to the same place. The ending spot, either way, is this line right here. So those two angles are called coterminal to each other. What's another way to describe that spot? 60 degrees. And I'd like you to think about a negative degrees. There's a student who needs to put his cell phone up on the front ledge up here. You can just bring it to me. I'll put it up there for you. Thank you, sir. Let's stay focused. All right, so there's negative a whole bunch of degrees, right? How much is each of these? Say it if you know it. I'm not going to wait for hands, just say it. What's that? Okay, those are that would assume that we are doing 1 radian for each chunk. Those are not 1 radian chunks. Those are pi over 3 chunks. 60. Negative 60, negative 120, negative 180. See what I'm doing here? Add another 30, or sorry, another 60, and then add another 60, and we're at negative what? A little louder. Yeah, negative 300. Those 4 are all called coterminal angles. They all look different. Obviously, they are different than each other. Another word, fancy word for that is distinct. Those are all distinct answers, but they end in the same spot, so they're called coterminal. Co means like the same, and terminal means like where you terminate. They all terminate in the same spot, coterminal angles. All right, let's see if you're really understanding that. Here's where pi is. What do you think that is? I'm trying to make a 45-degree angle here. So I could say it's 45, but it's pi over something. It's a fraction of pi. Oscar, what do you think it is? Is it half the way to pi?
Sorry, I don't know.
I'll come back to you. John and Jack. This is pi over 4. It's a fourth of the way to pi right here. This would be 2/4 of the way to pi. You might be like, but that's 1/2 pi. Yes, it is. And this would be 3/4 of the way to pi. Catching on? Okay. So if this spot right here is the key spot I'm thinking of, is there another way to say, another way to get there? It's a little bit like, there's a ski hill that I like to ski in. It's called Welsh Village, and it's south of the Twin Cities. Is there more than one way to get there? Yeah. But all the different ways I could describe to get there are going to be ending in the same spot. Okay? So give me a coterminal ending in the same spot. Answer, that isn't 45 and it isn't pi over 4. What's another way to say that spot? Say it. -5 pi over 4. I'm going to check you. Here's -1 pi over 4. Here's -2 pi over 4. Here's -3 pi over 4. Here's -4 pi over 4. Here's -5 pi over 4.
So you have to go all the way to...
We need to keep going. So this is -6 pi over 4. This is -7 pi over 4. Hint, would you agree that if you would just went one more step, it would be -8 pi over 4, which would be right back to that spot? Okay, so it's -7 pi over 4. Thank you for trying, though. Appreciate the effort. Okay, so -7 pi over 4, and then there's one more with a negative number of degrees. You can use your iPad's calculator if you want to. -315, he says. Let's make sure he's right. Here's how I'm going to check it. If I add 45 more degrees, I should get 360. So 45, 15, 50. See, oh, -315 is absolutely right. See how I did that? Because it would be -180 to get here. Negative a bunch more. I like to even think of that as, if I went all the way around, it'd be -360. But I didn't go all the way around. I subtract off the 45. -360, take off the 45, -315. All right. Let's do one more like that. Negative pi over 6. Everybody draw where that angle starts and ends. Negative pi over 6. Hint, they always start in the same spot. And then where does that angle end? Okay, this is a super important time. Focus, because if you don't get these circle trig angles down, it's going to be such a big deal. So stay focused. This is negative direction. It always starts here, and then it's got to go 1/6 of the way to pi. And here's where pi always is. -1/6. That's about there. Here's 2/6. Here's 3/6. That's the way you can check yourself. Because if you're dividing it up and you go, okay, that's 3/6. Does that make sense? Yeah, because that's halfway to pi. That is -3/6 pi. Okay, so what I wanted though was -1/6 pi. So these are not necessary. My final answer is that blue angle right there. And then they might say, find 3 other names for that spot. One could be a negative number of degrees. One could be a positive number of degrees. And one could be a negative number of radians. Hint, you'd count a whole bunch of pi over 6s to get there. All right, find me 3 other names for negative pi over 6. I cannot overemphasize how important this is. I don't want to underemphasize how important this is. It's literally until May, from now till May, like we'll have some 70-degree days going on by then. Okay, and right now, really yesterday, it was like still below zero. From now till then, it's trig. And trig always depends on radians, and this is the moment that we're really getting that down. It's huge. Okay, I'd like you to compare with the person across from you. Sometimes you have to go diagonal. In these two rows, we're gonna say you three work together, you two work together, and you three back here work together. See if you got the same things. If you need help, ask for help. Okay. So, here's how I would have thought it through. Well, first I'm going to figure it out in degrees. So this would be, this is like 180. 180 divided by 6 is 30. Another way to think that through is 30, 60, 90 degrees. Okay, so that's negative 30 degrees. Awesome. Another way to do it, all the way around the horn. And that would be a whole bunch of positive pi over 6s. 6 pi over 6 gets me to here. And then this would be 7, 8, 9, 10, 11 pi over 6. Raise your hand if you had 11 pi over 6. Awesome. And then last but not least, a whole bunch of positive degrees. So this would be 180. Well, I'd like to actually do it with 360, which would be all the way around. 360 is like all the way around, but then I subtract off the 30, positive 330 degrees. Okay, there's my, with the original up from up here, my 3 plus that one makes 4 answers. Do you get coterminal? Okay. All right. If not, then you're going to have a chance to practice that tonight. Strongly recommend. All right, moving on. The other concept depends on this. Do you remember yesterday me talking about changing from radians to degrees and you needed to multiply by facts? Here's a fact. 180 goes with pi. Remember this one? So what if I had 5 pi over 4? Would you please multiply those two together? It'll change from being in pies to being in degrees. And then you'll just need to simplify it. And remember, my best advice is if you can factor it, you should. So I'd break this up, this 180, into 4 times something else. Because why do I want the 4? Because these will cancel then. 4 times what makes 180? Help me out. Yes. 45. That'll help you to make this cancel easier and nicer. This pi, gone. This 4, gone. So it's just really 5 times 45 degrees. 5 times 40 is 200. 5 times 25, so 225. Raise your hand if you had that one right. Okay, awesome. Now, something like that is changing. If I see, this morning I saw a bug crawling on a shirt at my house. I'm like, where the heck have you been? I guess he's been inside the whole time, right? Because there's no bugs alive outside, that's for sure. I mean, they may be in hibernating mode or something, but there's one in my house. So he's crawling along super slow. It's just like almost like he's in hibernation mode. So let's say he goes 2 feet per hour. Seriously, he was probably moving that slow. Can I figure out that speed in inches per second? All right, so here's what you do. You start with your 2 feet per 1 hour. I would always give it units, a number and some units on the top and the bottom of every single one of these fractions. And if any of you guys have ever done dimensional analysis, this is that. It's also known as stoichiometry, if you're in chemistry. Anybody heard of or used either of those 2 words? Oh, good. Okay. So then, do you get, I need feet down here? Why? To cancel the other feet. We want this to cancel this. Now we always use facts. Remember that 180 goes with pi? That's a fact. Doesn't help us right now, but what's a fact about feet that we know? 12 inches, 1 feet. Cool, that cancels. Now I'm in inches per hour. Just one more little multiply. I can even do it over here, by the way. It's a good method if you run out of room. I need that hour to cancel, don't I? So I put an hour here, and then I just think, what's some fact I know about hours? That helps. 60 minutes. In fact, let's go right to seconds, just because it'll be faster. How many seconds are there in an hour? 3,600. Very nice. Notice I better be careful with the units. And then I go hours cancel. Yay! My answer's in inches per second. I just have to multiply across the top and multiply across the bottom. So I got 24 over 3,600. And that's on the top, it's inches, and on the bottom, it's seconds.
You can take it to lower.
Yeah, you can definitely reduce it. We can cut it in half. That's always an easy way to start. If I cut it in half, it would be 12 over 1,800. And then I can cut them in half again, 6 over 900. Cut them in half again, 3 over 450. And that's 3 inches in 450 seconds. That's how fast the bug was moving. Okay, now here's one where we need to change rotational motion into straight line motion. Imagine you have a saw blade. These are like the little pointy things on the saw blade. And it's spinning around really fast. And you put a little fleck of red paint right there. If this thing is doing 2,000 RPM, I need to make that into a fraction. Rotations per 1 minute. RPM stands for rotations per minute. Notice I have a number and a unit. On the bottom, I have a number and a unit. Okay, now this time, the challenge really is to figure out what the heck a rotation is. Well, I need to give you more info. What would you need to know about the saw, Jack?
I did the diameter of the radius.
All right, let's say I told you the radius of this thing was 8 inches. An 8-inch blade. Okay. 8 inch. An inch matters here, right? Then is my one rotation 8 inches? No. I got to be smart about this. A rotation is a circumference, and I find that usually only half the class knows this formula. If you know it, write it down. Circumference is what? The heck is circumference? Is it like radius squared? No. Is it just double the radius? No. Everybody write it down, and then I'm going to see how many of you feel confident you've got it. Circumference is what? Now raise your hand if you're confident. Okay, not too many people. All right. What do you say, Mr. T?
2 pi r.
2 pi r is correct, sir. You could have said pi times diameter, because d would replace the 2 r's then. That's totally fine. But we have a radius, so why don't we use this one? I like it. So then would you agree the circumference is 16 pi? Then that means that that little red fleck here on the end of the saw blade would go 16 pi inches in one rotation. I have now got it out of rotations per minute, and it's now in what per minute? Pi is not a unit. It's just a number, 3.14. Inches per minute, yeah. Now let's get it to miles per hour. That's a typical one we do. And I'm going to warn you, we will not give you this number. You got to have it memorized. And it has to do with feet. But we don't want to get it to miles quite yet. We just want to do one little change at a time. Do you get, we need a minutes here to cancel the minutes. What's a fact we know about minutes that's going to get us closer to our goal, which is miles per hour? 60 minutes is 1 hour. Excellent. Minutes cancel. Now I'm down to inches per hour. Ooh, I'm getting kind of close because I already got the hours part right. Okay. What's left? I would always go like this and I'd say, well, I got to get rid of hours. No, I don't. I don't need to get rid of hours. Got to get rid of inches. Inches would be good to get rid of. So there's inches here, so I put inches there. And then I think, what's a fact I know about inches? That's going to help. Yes?
In 1 feet, there's 12 inches.
All right, so 12, 1 foot. Excellent. Inches are gone now. Now my units are feet per hour. I'm getting closer. Now the last one is the one that I told you I wouldn't tell you on the test, but you need to know. Does anybody have it memorized already? Yes, sir.
5,028.
Yep. 5280 feet. Why am I putting it on the bottom?
Cancel.
So that the feet will cancel the feet. And that's 1 mile. I've heard it said 5 tomato feet. What? 5280. Anyway, this cancels. This cancels. Miles per hour. Sweet. I'm done. All of these numbers that are left get multiplied. Timesing by 1's kind of irrelevant, right? And then all the numbers on the bottom get multiplied. I'm ignoring my 1's again. So 2,000 times 16 times 60 over 12 times 5280.
Oh, would have to be 16.5.
Oh, I forgot the pi. Sorry. Thank you. Good point. And the pi can go anywhere. I'm just put it at the end here. Pi is a number. It's 3.14. Don't forget that's not some weird angle. It is confusing because we're in that unit where whenever you see pi, you think maybe radians. But it still means 3.14, even when it's in a radian. Okay. And that was in miles per hour. That's everything. Taught you everything that you need to know. But I think we need to practice a little bit. And we need to review yesterday. So here's some stuff. First off, here's yesterday. What is this blue area called? Say it if you know it.
Radian.
That is not a radian.
Arc.
That's an arc length. Good. If this, and this are all the same, then what's this?
Radian.
A radian. If they're all equal, then the angle there is a radian. Does that look a lot like 60 degrees? It should, but it's not 60 degrees. It's just really close to 60 degrees. It's like 59 degrees. That's because it takes 3 of them plus a little tiny bit more, 3.14, also known as pi, to get there, and that's 180. Then I also asked you yesterday to know how to find the area of a sector and how long this would be. So I'm going to give you a problem like that. Here is a typical question. Let's say that this is a 45-degree angle. Let's say that this is a circle. Now, you should already be able to go in your head, oh, I can change that to radians. How far is it to pi? Is it half the way to pi? No. Is it a quarter of the way to pi? Maybe. Is it a third of the way to pi? Definitely not. Okay, so figure out how many pi that is. Because you need it. Because S equals theta R is the formula. You need to find this length. The last thing I got to tell you is the radius. Let's say the radius here is 10. Would everybody please figure out how long that little arc is? And compare with the kid next to you. Pro tip, don't forget to change it to radians. Because it's the radians times the radius. Leave your answer as like a nice clean answer. Don't go get a decimal for it. Saying something like 3 pi is better than like 27.3. All All right, compare with the kid next to you. If you don't understand this, you probably are dumb. If you don't understand it, ask them.
So you have to change this to the radian or whatever. And so when you have to do pi over 180, and then that just simplifies down to 1 over 4, and then times 10. That's the radius.
All right.
And that just simplifies down to 1/4.
All you do is pi over 4, and then you times it by 10. How to get the pi over 4? It's 1/4 of the way to pi. Okay, so then times the radius is 10. So then it's 10 pi over 4. Hope you simplified. 5 pi over 2. Raise your hand if you had that one right. Sweet. Remember, it's a length. So if I actually wanted to know how long it was as a decimal, I'd go 5 times 3.14 is about 15 divided by 2, which is about 7.5. And if you look at this, does that seem like it could be 7.5 compared to the other one's 10? Yeah, seems somewhat reasonable. Okay. All right. Next, I want you to find how big the sector of the circle would be. A fraction of the whole pi r squared. Okay, so I'm going to do this one. It was pi r squared, but a fraction of pi r squared. I personally would try to do this 45 out of 360 in my head, and I'd think, what part of the whole is that? It's like a pizza been divided into 8 spots, and I have 1/8 of the pizza. So I'm going to say 1/8 of pi r squared, but r is 10, so that 10 squared is 100. So 1/8 of pi times 100. So it's 100 pi over 8. Simplify it down, cut it in half each, maybe 50 pi over 4. Half again, 25 pi over 2. Raise your hand if you had that one right. Sweet. Any questions? Okay. You sure? You can ask me. Let's get the letter not understanding this because of their faces. Okay. All right. So then let's go through all the notes here quick. What is a radian again? Would you draw me the picture of a radian? Just draw the picture of it. If you don't know what I'm talking about, you start with a radius. And then you draw another radius, and then you connect them. If all these are the same, like 8, 8, and 8, then that's a radian. It's a little angle that gets formed if those are all the same. It's about 59 degrees. I'm rounding. Totally, it's not. That's just a kind of a ballpark. Just less than 60. Okay, good enough. We already practiced this, but what would be your first step? Yes? Convert to radians. That would have to change to a radian. If you're bad at that, you go this way. If you're good at that, you go, ooh, that's 1/4 of the way to pi. Pi would be over here, and it's therefore pi over 4. And you can do it so much quicker. Okay? This 120, I'd think of that as 260s. And if you memorize the base ones, this would help you so much. I'm just going to tell you if you're good at memorizing, here's the base ones. 30, 45, 60, and then the big one, of course, 180. If you've got all these base ones memorized and you know this is pi over 6, and you know this one's pi over 4, and you know this one's pi over 3, and 180 is pi, you can get pretty much anything you want after that. You can like figure out, let's say 120. Well, that's 2 of these. 2 60s would make 120. So a 60 is pi over 3. And if you want to 120, you're going to get 2 pi over 3s. Does that make sense? All right, better memorize those. Because I think you'd get 90 by knowing this one. If you know 180 is pi, then do you get that 90 would be half of that? Pi over 2. If you don't, if you want to just put that on your list, you should know that one too. But I think knowing pi is 180 would get you most of these. And last thought, if each of these is 180, 180 divided by 6, 30. 180 divided by 4, 45. 180 divided by 3, 60. 180 is 180. See what I mean? If you just think of the pi as 180, it helps a lot. Moving on. This is where we were talking about different ways to say this spot. So they're saying if this right here is 120, this right here is 120, then this right here would be negative 240. And 120 is here, and negative 240 is in the same spot. They're coterminal. If you want to say those in radians, I'd say that's like 2 60s. And I know 60s are pi over 3. So 2 pi over 3. If you don't like to do it that way, you can memorize it another way if you like. But if I know that 60 is pi over 3, and this is 2 60s, then it's 2 pi over 3. This spot here is 2 pi over 3. And last but not least, I can go around this way. And that would be a negative number of pi over 3s. This is negative 3 pi over 3. One more. Negative 4 pi over 3. That's the concept of coterminal. There's the written out if you're the type of person who likes to see it all written out. Alright, moving on. And moving on again. And we already did problems like this. This is that angular velocity thing. So they show an example of a person spinning something around them. I give you the example of a saw blade that was spinning this way. And it could be a tire spinning. But a lot of times the circumference formula is what you need. Do you still remember it? Because one rotation is one circumference. And a circumference is pi times diameter, or what's the other one? 2 pi r. You really need to know that formula. Okay. Here's an example of a word problem about that. And they tell you the diameter of the yo-yo. I'd be drawing the yo-yo and saying, okay, it's 2.25 across here. That means I use the radius, of course, is more important. Cut your diameter in half, use that. And it says revolutions per minute. That's the same thing as rotations per minute, RPMs. And you'd start with that, and I go 4,500 rotations per 1 minute. And then I'd multiply by a whole bunch of things until it finally turned into miles per hour. Okay? And what's that key number that you always have to have memorized? 5,280. At some point in here, you'll be multiplying by 5,280 feet per 1 mile. Okay. And this is where it starts the actual homework. So, I'm going to strongly recommend that you do several problems from this page. And this page is also crucial. Like, seriously, this is like learning how to add. Do you agree that later on you can look back and say learning how to add was super important because you still do it today? Even in the middle of every problem, you've got to add. Okay, if you can't get adding down, the whole rest of your math career is toast. It's kind of like that. If you don't get radians now, you don't have to get it today, but you need to get it in the next couple days. Otherwise, you're going to be so confused later. I've got to get these radians down. Take the time to memorize them. And then here's a nice example of a few word problems. And then that's all I've got for you for today.